Chapter 1.7.1 Configuration Best Practices. The document provides configuration best practices from various sources, such as user guides and examples. It is continuously updated and open to suggestions from users. If you have any additional tips or recommendations that could benefit others, you are encouraged to submit them through filing an issue or submitting a pull request. General configuration tips. When defining configurations for clusters, always specify the latest stable API version and store configuration files in version control before pushing them to the cluster. This allows for quick rollback of changes if needed and aids in cluster recreation and restoration. Write configuration files in YAML instead of JSON, as YAML is generally more user-friendly. Group related objects into a single file for easier management. Use annotations to provide object descriptions for better introspection. Avoid specifying default values unnecessarily to minimize errors. Be aware of a breaking change in YAML versions regarding Boolean values. YAML 1.2 only recognizes true and false, while YAML 1.1 also accepts yes, no, on, and off. Kubernetes uses YAML parsers mostly compatible with YAML 1.1, so using yes or no instead of true or false may cause unexpected errors. To avoid issues, always use true or false for Boolean values and quote strings that may be confused with Booleans, like yes or no. Refer to the YAML specification changes documentation for a comprehensive list of changes between YAML versions. Naked pods versus replica sets, deployments, and jobs. It is advised not to use naked pods, which are pods that are not bound to a replica set or deployment, unless absolutely necessary. Naked pods will not be automatically rescheduled in the event of a node failure. It is recommended to use a deployment instead, which creates a replica set to ensure the desired number of pods is always available and specifies a strategy for replacing pods, such as rolling update. Using a deployment is preferable over creating pods directly, except in scenarios where the restart policy is set to never. In some cases, a job may also be appropriate for managing pods efficiently. In Kubernetes, it is important to create a service before its corresponding backend workloads, as well as before any workloads that need to access it. This is because when a container is started, Kubernetes provides environment variables pointing to all the services that were running at the time. If a pod wants to access a service, the service must be created before the pod to ensure that the environment variables are populated correctly. While DNS does not have this restriction, it is still recommended to use a DNS server as a cluster add-on in Kubernetes. The DNS server watches the Kubernetes API for new services and creates DNS records for each, enabling all pods to automatically resolve service names. It is advised not to specify a host port for a pod unless absolutely necessary, as it limits the scheduling options for the pod. Instead, consider using node port services for exposing a pod's port on the node. Additionally, it is recommended to avoid using host network and use headless services for service discovery when load balancing with kubeproxy is not needed. Using labels. Labels in Kubernetes are used to identify semantic attributes of applications or deployments, such as naming, tier, phase, and version. These labels can be used to select pods for other resources, such as services, based on specific criteria. By using standardized Kubernetes common labels, tools like kubectl and Dashboard can work in an interoperable way. Services can span multiple deployments by omitting release-specific labels from their selector. When updating a service without downtime, a deployment is used to control the rate of changes to the desired state. Manipulating labels can be used for debugging purposes, as removing relevant labels from a pod will prevent it from being considered by controllers or serve traffic by services. Using kubectl label allows for interactive removal or addition of labels. This approach is demonstrated in the Guestbook app. To apply Kubernetes configurations from a directory, use the kubectl apply f directory command with .yaml, .yml, and .json files. For get and delete operations, use label selectors instead of specific object names. Utilize labels effectively and refer to the sections on label selectors for guidance. To quickly create single container deployments and services, use kubectl create deployment and kubectl expose. An example of accessing an application in a cluster using a service is provided in the documentation. By following these suggestions, you can efficiently manage Kubernetes configurations and services in your cluster.